Section 3.5, Graphing Linear Inequalities. Inequalities in two variables. So first, let us recall what standard form is for a linear inequality in two variables. And so it's an inequality of the form where y is less than mx plus b, or y is less than or equal to mx plus b, or y is greater than mx plus b, or y is greater than or equal to mx plus b. So if you can solve your inequality and put your y on the left-hand side of your inequality, then we say it is in standard form. Well, it may be that you can't actually solve this inequality for y because there is no y, in which case x less than a, x less than or equal to a, x greater than a, x greater than or equal to a. Then I would say that this is in standard form. So let's do some examples. Let's say on page 135, let me do let's say problem number 2. And so I have here x plus y is less than or equal to 3. In exercises 1 through 12, identify which side of the line should be shaded to represent the solution region of the given inequality. So they've already given us the graph of the boundary line. Then what we want to do is determine on which side to shade. Okay, so let's do that. So the first technique that I'm going to show you is just to check to see which side of this inequality gives us a true statement. So I can pick any point in the plane that is not on the boundary line. So let's pick any point except for any points along this line. So let's check at the origin. If I'm able to check at the origin, then do that because that's the easiest place to check. And so is 0 plus 0 less than or equal to 3? And so the answer is, well, yes, certainly 0 is less than 3. So that's a true statement. Therefore, on this side of the equation, it's true. And so I should shade, and maybe I'll do it, let's say with blue or something. Let's do it with orange. Then if I shade this side of the equation, then this will be the solution to this particular inequality. And so I can say that, well, this side is indicates my solution. So we shaded the side of this line, this boundary line, that contained the origin because the inequality was true at the origin. Therefore, it is true on the same, all other points on the same uh, side of the line will also be true. Similarly, if I pick some point and it was false, then every point on that line, on that side of the boundary line, would also be false. And so that's one way of graphing. Another way is, well, to note if I have less than is true below. If I have greater than, it's true above. The boundary line. If I do not have an equal sign, then the boundary line is dashed. If I have an equal sign, then the boundary line is solid. Do not have an equal sign, so the boundary line is dashed. Have equal sign, so the boundary line is solid. Similarly, well, if I cannot solve for y, if I just have x, some inequality a, then, well, that's going to be the boundary line will be a vertical line. So there's a right and a left, not above or below. And so x is less than says it is true to the left. And so less than or equal to, so it's true to the left. Greater than, it is true to the right. Greater than or equal to, it is true to the right. And again, if there's no equal sign, then it'll be dashed. The boundary line will be dashed. If there is an equal sign, then the boundary line will be solid. No equal sign, boundary line dashed. Equal sign, boundary line is solid. Okay, so this will give us a further technique to be able to graph inequalities. So let's suppose I want to do, let's say, problem number 16. X plus y. Actually, let me do 15. 3x minus 2y is greater than 2. Okay, so let's do this. So let me first solve my inequality for y. So subtract 3x from both sides of my inequality. So I have a negative 2y greater than negative 3x plus 2. Divide both sides of my inequality by a negative number. The negative 2's cancel, so I get y. Since I'm dividing by a negative, the inequality reverses. Less than. Negative divided by negative is positive. Positive divided by negative is negative. Okay, so we have here the following. Let's try to graph the inequality. So let me put some tick marks. Okay, so the y-intercept in this case for the boundary line is -1, and the slope, maybe I'll write the slope first. The slope of my boundary line is 3/2, and so I have a rise of 3 and a run of 2 with a y-intercept equaling -1. Actually, let me give a little bit more space here. Okay, let me see if I can grab this successfully. Okay, well, close enough. Okay, so I have a y-intercept of -1, and then a run of 2 and a rise of 3. Okay, so I have these 2 points on the boundary line. Notice that there is no equal, so this is a dashed line, so the boundary line is dashed. And it's going to be true below. Okay, so let's draw the boundary line, so it's going to be a dashed line. Okay, and it says here that it is true below. And so below the line, so I can shade below. So let me shade below. And so this is the solution. And now let me mark that this is my solution. And I am done. Let me do problem number 18. Two x plus 3y greater than 3. Subtract 2x from both sides by inequality. And now let me divide both sides by inequality by the positive constant 3. Since I'm dividing by a positive constant, my inequality is not going to switch. So y is greater than -2/3 x plus 1. So the slope equals a -2/3. So I have a y-intercept of 1. And so I have a rise of -2 and a run of 3. Since there's no equal sign, my boundary line will be dashed. Since it's greater than, it will be true above. So let's try to draw this. Let me put some tick marks. 4, 5, -1, -2, -3, -4, -5, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Y-intercept is +1, I go down 2 and over 3. And it is a dashed line. So it should look something like, okay, try that again. Okay, good enough. And it is going to be true above. And so I can shade above. And that is my solution. And now let me indicate that it is a solution. And that is my answer. Let me do problem number 26. Two x less than or equal to 4. Let me divide both sides of my inequality by 2. So I get x is less than or equal to 2. So you notice that in this case, the boundary line is a vertical line. So that's what my boundary line will be. And it will be true to the left. And it will be a solid line. So a solid vertical line. So let's do that. Actually, I can probably do it here. Let me not try to collide with that one. One, two, 1, 2, 3, 4, 8, 9, 10, 11. Who cares? -1, -1. And so it is a solid line. It's vertical. And it is true to the left. Oh, okay. So I have that this over here is my solution. Okay. Let me do problem number 40. 2 y minus 4 plus 2x greater than or equal to 3y minus 2 minus x. Let me multiply 2 inside the parentheses, a -1 inside the parentheses. So I have 2y minus 8 plus 2x greater than or equal to 3y minus 2 plus x. Let me subtract 3y, add 8, subtract 2x from both sides of my inequality in order to isolate y on the left-hand side of my inequality. So I get a negative y. Everything else cancels, greater than or equal to. The three y's cancel. A negative x plus 6. Let me divide both sides of my inequality by negative 1. And so I get that y, again, since I'm divided by a negative, I'll have to reverse the inequality. So less than or equal to negative divided by negative is a positive x. Positive divided by negative is negative. So I get that the slope is 1 and the y-intercept is negative 6. So I have a rise of 1 and a run of 1 and a y-intercept of negative 6. This is going to be true below, and the boundary line will be a solid line. So let's draw this. Try to make it a little bit straighter if at all possible. Well, I guess not. Oh, that's going to be negative 6. That's way down there. Okay, so let me draw this again. So this is a y. Oops. Don't like that. That's y. So, and that's an x. So 1, 2, 3, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9. 1, 2, 3, 4, 5, 6. Negative 1, negative 2. Okay, so it's solid line. 1, 2, 3, 4, 6. So that's 6. 1, 2, 3, 4, 5. And that's 6. Let's see if I can make it. Ooh, actually, I think I did. So it's a solid line, and it's true below. So let's shade below. And so it should look something like this. And so all out here is my solution. And then let me indicate that this is a solution. To this particular equation, to this particular linear inequality. So this is my, and it is solid line, solution. And so that finishes off section 3.5.